Welcome to Code Design. In this session, we'll be discussing Range Sum Query Immutable Leetcode 303. So let's look at the requirement. We have given an array of integers and there will be multiple range query on that array. So what is a range query? The range query, they will be given a left index and a right index, and we have to find out the sum within that left and right. And the condition is left less or equal to right, and it is inclusive. So let's understand with the example. So this is our array A. In this array, we have -2, 0, 3, -5, 2, -1. And our first range query is 0 to 2. That means this is index 0, 1, and 2. That means the answer will be -2 plus 3 because -1 for this query. Another query we have 2 to 5. So this is our 2 to 5 from index 2 to index 5. So what will be 2 to 5? 5 -6. So -1. And so this sum range will be called at best 10,000 times. And what is the range for each element in the array is -10 to the power 5 to +10 to the power 5, -100,000 to +100,000. So this is our constraints. So what would be the naive approach to solve this problem? Just write a loop where I would be left and I would be less or equal to right, less or equals right, and then we sum up from all the elements left to right. So this works for a few queries, 1, 2, 3, but in this program there will be at least 10,000 queries. So for 10,000 queries, it will be an expensive operation. M is our number of queries. If M is our number of queries and each of the query takes on time, then it would be MON. So max 10,000, 10,000, and O of n. And what is our array length? Array length also 10,000. So the naive approach is inefficient. So how we can do it better? We can do it better by using a pattern or technique called uh, prefix sum. So what is a prefix? Um, for these 2 to 5, right? For these 2 to 5, the prefix is this part before index 2, index 0, and index 1. So whatever sum, what we can do, we can calculate the sum for each of the indexes in a O1 time and store the sum. If we store the sum, then what we can do for this operation, 2 to 5, we have the sum for this index, right? Say the sum is -3. This index means running sum means the sum from here to here all the way. And we can see that before 3, before this index 2, we have sum -2. So what would be our result for this query 2 to 5 for index 2 to 5? 2 to 5, our result would be -3 minus -2. So which is -1. So that would be efficient. We'll calculate running sum for each of the index. And what would be the range sum query for 0 to 0, 1, 2, right? Now for this case 0 to 2, 0, 1, 2, what is the running sum at this index? Index 2, -2 plus 3, 1. But what is the running sum before that? Before index 0? We don't have a running sum here, right? So our left would be, if we want to, left is 0, there is nothing before left. So basically this result would be num of right minus num, just num of right, because left is 0. So we'll see in the code. Let's go and implement it. So what we need to do, we need to create a variable running sum equals 0. We need to create an integer array. We can call it prefix sum, and here prefix sum equals new integer array nums dot length. So we create the prefix sum array. The length would be this, our given array length, and then for integer I equals 0, I less than nums dot length I plus plus running sum plus equals nums of I. So we are calculating running sum for each of the indexes starting from 0. And what we need to do, prefix sum of I equals running sum. We store the running sum in our prefix sum so that we can do the range query on this prefix sum array. So what I was saying, for the use case 0 to 2, nothing in the left, right? There is no index before the 0 index. So what happened in that case? If our left equals 0, we return prefix sum of right. Because if our left index is all the way here 0, 0, then no index before 0. So we don't need to deduct anything. Whatever is our value here on the right side, that would be our sum. And for all other case, we can do return prefix sum of right minus prefix sum of left, but it's inclusive, right? So it would be again, let me quick draw. So if our example is -2, 0, 3, and the query is from 1 to 2, then our right is 2. And what is our left? Left is this one, index 1. So what we have to deduct from the whole sum, from the running sum here, 3, which is -2 plus 3, 1, we have to deduct this guy. So what is the value of how we can get the running sum for this one? This is our left, right? So that would be left minus 1. Because left and right is inclusive. This is our left. So left minus 1 means whatever we have prefix sum for left minus 2, minus 2. And what is our prefix sum of left is 1. So it would be 1 minus minus 2, 1 plus 2 equals 3. So our sum for this range 1 to 2 is 3. So that's it. It's an easy problem in Leetcode. So let's run it. Okay, we got some compilation error, semicolon missing. Okay, let's submit it. Okay, it got accepted. It beat 64.70% of all the submissions. So what is the space complexity? We know time complexity is M O1. This is our time complexity. Because what you can see here on the sum range, we are just getting the value at index right and deducting the sum for prefix sum for index left. So prefix sum of index left actually prefix sum of left minus 1. So O1, O of 1 is the time complexity for each of the call of sum range. So if there is M call, that would be our overall time complexity. For a single call, time complexity is O1, which is efficient. And what is our space complexity? Is On, because we are using this prefix sum array for pre-calculate the prefix sum.